learning outcome 5 says state the difference between speed and velocity. So really, to define the difference, we're going to define what both mean. Right? So speed is the distance travelled per unit of time. And it is a scalar quantity, although we've actually already defined that, haven't we? Now the units that we'll use, because there are other units, are kilometres per hour, which you write, oops, sorry, I've actually done that wrong. km h to the minus 1. I'll talk a wee bit more in a second about that minus 1, but that means per. Right, so the minus 1 above the h means per. Or meters per second. So once again, the minus 1 right, above and to the right of seconds means it's per second. Now notice we won't generally use miles per hour, they're imperial units. So kilometres per hour or metres per second. Now, in the formula sheet, you're given the formula d equals vt. You're probably familiar with v equals d over t, but in the formula sheet, it's d equals vt. And that's the one that I would suggest you use because it's easier to rearrange. All right, d stands for distance. V stands for speed. Now that's one you've really got to watch. Okay. V is our symbol for speed and T is our symbol for time. The units, well, we've got kind of units that can go together. If we measure our distance in kilometres, then our speed would be in kilometres per hour and our time would have to be in hours. Or if we're doing it in a lab, so that would make sense for, say, a car or an aeroplane or something like that. In a lab, you're usually dealing with smaller distances and smaller times, so we'd usually use metres per second, so we can group those three together. Distances in metres, time in seconds, giving you your speed in metres per second. That make sense? Now, in a very similar way, velocity is a displacement per unit of time. And it is a vector quantity. So kind of two key differences there between speed and velocity. Speed is the distance per unit of time, it's a scalar. Velocity is the displacement per unit of time, it's a vector. But we use the same units. The formula is very similar as well, but here's where it gets even more annoying. These are the internationally agreed symbols, so we can't just change them because you might find it a wee bit confusing. You need to get to know them. The symbol for displacement, believe it or not, is S. Right? The international symbol for displacement is S. So in that formula, the S stands for displacement. Right? Not to be confused with speed, please. Okay, so very similar idea, and I'm not going to write out the units again because we've got them up above. S is displacement. This V stands for velocity, and the T is time. Now I agree that can be a bit confusing, but like I say, they're internationally agreed symbols, so we can't just change them for your benefit, I'm afraid, much as we might want to. So the journey shown in LO4, learning outcome 4, takes 5 seconds. Calculate the speed and velocity. Okay, so from learning outcome 4, we had that the distance was 7 meters and the displacement, right, so we're now using a symbol S, was 5 meters bearing, was it 127? Somebody's got it right in front of them. And from this question, we are told that the time is 5 seconds. So to calculate the speed, right, we're going to use the D equals VT formula. Substitute that D is 7, V is what we're trying to work out, and T is 5. Rearrange, I'll just swap sides to start with. Divide both sides by 5. And we get that the speed then is 1.4. And our units there, ms minus 1 meters per second. For velocity, very similar, except the formula here is S equals VT. Now what we do is we substitute the size of S. So we substitute the 5 in instead of the S. And the bearing basically just carries over. It's the same bearing. It's only the magnitude of the displacement you need to divide by the time. So we get V times 5 equals 5. Divide both sides by 5. And you get V equals 1 meter per second. So the velocity is 1 meter per second. And we copy the bearing. It's bearing 127 degrees. Learning outcome 6 is to describe how to measure an average velocity. So when we're describing an experiment, it's always a good idea to start with a diagram. Right? So whether it's a person or a car, right, or one of these wee dynamics carts that we're going to use, what you need to do is you need to have a clear distance that you're going to do the measurement over. Right? So you need a starting point and an end point. Okay? A couple of asterisks marked A and B. And for us, when we do it tomorrow, you're going to have the wee cart. Right? And it's going to make its way past, right, from A to B. Now we'll describe it as measuring average speed. If it was average velocity, then you would just, instead of saying measure the distance, you just say measure the displacement. And any time you're describing an experiment, when you're saying you're going to measure something, you've always got to make it clear what you're measuring with. So measure the distance between A and B using a meter stick. Okay, measure the time for the cart to travel from A to B using a stopwatch. Sorry, I should have put this in at the time. I'm going to put in brackets after the first sentence D, right, so I'm clear, right, that's the distance, and T in brackets after the second one, so I'm clear that's the time. Then use the formula D equals VT. To calculate the average speed. Now, just to help distinguish between speed in general and average speed, we put a wee bar above the V, so I'm going to put that in the formula as well. Right? That indicates clearly that you're dealing with average speed. Can you also see there that my description, when I talk about, if a teacher says to you, you need to be more precise or you need to give more detail in your descriptions, hopefully this is a clear example. I don't just say measure the distance. I'm very clear that I'm measuring the distance between A and B. I don't just say measure the time. I'm very clear about what time it is that I'm measuring. Okay, so that's the kind of habits we want you to form when you're describing things, right? Whether it's experiments or just things in general in your work in physics. Right? Always try and give as much detail as you can in your answer.